Previous videos on trig graphs looked at the graphs of the sine and the cosine functions. The interval between 0 and 360 degrees is one period. These 5 key points are important where the graph meets the x-axis and its maximum and minimum turning points, same in the cosine curve. Under any transformation, we want to know the images of these points. We give their coordinates. Transformations in previous videos covered were of this type: y equals a sine bx plus c, where a, b and c are 3 numbers. You can either be affecting the input to the function, that's the x value, the x coordinate, the angle, or the output, that's all of the function sine x. So here the b is going to affect the x coordinate. Now the a multiplies all of sine x here, so a is going to affect the y coordinate, and then to the whole of this sine x, c is added on, so that will affect the y coordinate. So the y coordinates were affected by the multiplication by a and the adding on of c, whereas the x coordinate was affected by the b. So in these changes we're going to be looking at this now. The a is as before, it multiplies the y coordinate, but here we have adding in a number or taking off a number from x. So this is the general form. We're going to look at the effect that has. It should be only affecting the x coordinate because it's the input to the function, so it should just be affecting the x coordinate. In here, in the brackets is the input. This will not affect the y coordinates in any way, but this a will. Now, graphing package here, I'll illustrate it. Here's the sine curve. So that's y equals sine x, peaks at 90 degrees, 1. Minimums at 270 degrees, -1. Crosses the x-axis with the y coordinate 0 at 0, 180 and 360 degrees. Now, if I were to add in, let's say, 30 degrees here, so that's x plus 30, the x coordinate's going to get an extra 30. That means you can put in for x 30 less than you used to. That's why the peaks move from 90 degrees to 60 degrees. So when you give x plus 30 in the brackets here, you think of subtracting 30. You can put in 30 less than you used to. So 60, put in the brackets here, would make 60 plus 30, that's 90. So to make the peak 90 degrees 1, we only need x to be 60. In the same way, at 270 degrees here was the minimum. It's now 30 less at 240. Hit the x-axis at 180, and now hits the x-axis 30 less, 150. Hit the x-axis at 360, and it hits at 330. This point here at 0 degrees has moved to -30, so it would be off of any sketch between 0 and 360. So that's adding in 30 in the brackets. It actually takes 30 degrees off your angles. The x coordinates will lose 30. The graph moves left. Now if I was to put that back to the original, and this time look at x minus 30, there it is. When you put a value in for x, it's going to have 30 taken away. You've now got to put in 30 more than you did previously. That's why the graphs move 30 degrees to the right. The x coordinate will get 30 degrees higher. So when this says x minus 30 in the brackets, you add 30 onto the x coordinates. 90 degrees for the peak has become 120 degrees. The minimum at 270 has become 300. Across the x-axis at 180, it's now 30 more, 210. 0 degrees here has moved 30 to 30 degrees. And at 360 degrees, when it hit the x-axis, it now moves to 390, so it's off screen. So that's subtracting 30 in the brackets here. You add 30 to the x coordinates. Now it would be the same if you're dealing with the cosine. So that was the sine. Here's the cosine. The cosine's got a minimum at 180. It crosses the x-axis at 90 and 270. It peaks at 0 and 360. The changes are just the same effect as before. That's x plus 30 in the brackets. So the x-coordinates got an extra 30. So the x-coordinates can lose 30. Everything went 30 degrees to the left. So it peaked at 360, 30 degrees less, 330 it peaks. It went to its minimum at 180 and now it goes 30 less, 150. Crossed the x-axis at 90 and now crosses at 60. And it also crossed at 270 and now crosses at 240. So the graph has moved left. The x-coordinates have lost 30 degrees. And again, if I put this back to the original, and I move it 30 to the right in this case because it says minus 30. Now what's happening here is, because we're taking 30 away from x, we've got to make x 30 higher than it used to be. That means the x-coordinates go up 30 degrees. So it says minus 30, but you add 30 to the x-coordinates. Started at 0, add in 30, it starts at 30 here for the peak. So it peaks at 0, 1, it now peaks at 31. Now at 0 degrees it started part way coming up. Here it crossed at 90 degrees before and it crossed at 120. It went to its minimum at 180 and now it goes to its minimum at 210. It crossed the x-axis at 270 and it crosses at 300 degrees here. And at the end, when it was 360 degrees, its peak, it's now at 390, so it's kind of going off screen. So, same sort of business for the sine and the cosine. One other change in the transformation, which is you had before y stretches. This is multiplying the y coordinates by 3. So it peaked at 91, it now peaks at 93, it went to its minimum at 270 degrees, negative 1, it's now 270 degrees, negative 3. Stayed fixed at these positions because the y coordinate was 0 and you just multiplied them by 3, so it's still y coordinate 0. So that was a stretch, and all we've added in is that could shift left or right. So in this case, since I've taken off 30 in the brackets, the angles went up by 30 to compensate for this 30 being taken away. They have to go up 30 degrees. So the 90 position, 90 degrees was a peak, it's now 120. The minimum was at 270, it's now at 300. It crossed the x-axis at 180, it's now 210. It started at 0 degrees and it starts at 30. So when it was minus 30, it moved to the right 30. The x-coordinates had 30 added to them. And you could do the same with the cosine. So there's a cosine. It could be given a stretch. So that's 3 times the y-coordinate. It used to be 0, 1, it's now 0, 3. Used to be 180, negative 1, it's now 180, negative 3. That only affects the y coordinates. And if I make that, let's say, minus 30, it's moved 30 to the right. It used to be here at 0, 3, it's now at 33. Here, used to cross the x-axis at 90, it's now 120. Used to be its minimum at 180, it's now 210. Used to cross the x-axis at 270, it's now at 300. And the peak, which was at 360, has disappeared because it's now at 390. So this has moved at 30 to the right because your x has to go up by 30 to compensate for that minus 30. And of course, if we put this back to the start, if it had been plus 30, it would move 30 left. So because we're giving this an extra 30, we can take 30 off our old x coordinates. So what happened at 90 now happens at 60. What happened at 180 now happens at 150. What happened at 270 now happens at 240. What happened at 360 now happens at 330. What happened at 0 was going to happen at negative 30. It's moved off screen. So that's the changes. Basically, if it says plus b, you actually take b off the x-coordinates. If it says minus b, you actually add b on. Now, we sketch curves between 0 and 360 degrees. So when a phase change takes place, this is a phase change of 30 degrees, everything moves 30 degrees to the right. So that's y equals sine x minus 30. It meant your x-coordinates had to go up by 30. Because we sketch it between 0 and 360, it's chopped off at the end here. That position here is on a level with that position. And here's y equals sine x plus 30. That meant you can take 30 off your x-coordinates. Because you're given it an extra 30, you can take 30 away from your x. So it moves 30 left. Every previous angle, 90 went to 60, 180 went to 150, and so on. You start at 0 degrees, it comes round, and it stops at that position at 360. You're going to get questions. If you download the worksheets from the link in the description, you'll get worksheets which will, practice this. It will give you a general formula equals sine x plus or minus b. It will show you a graph, and it will show you one of the positions, 180 degrees, transformed. In this case, the curve has moved 20 degrees to the left. So it's a sine curve. It would normally hit at 180 degrees here. It's hitting at 160. So 20 degrees left. That means the peak, which used to happen at 90, now happens at 70. So this position is 70 degrees 8. So that's the maximum turning point, 70 degrees 8. So from 90, it loses 20, just like the 180 lost 20. Same way the minimum, which was at 270, it loses 20. It's now its minimum, 250. It reaches negative 8. Now, that means A has been 8, because it's oscillating around the x-axis, and it's been stretched up to 8. The y-coordinates have been multiplied by 8. So that's what makes that 8 sine x plus 20. That's the 8, multiplying the y-coordinates by 8. And the plus 20 is because the graph went 20 degrees to the left. There's the maximum. The 90 went to 70. There's the minimum. The 270 went to 250. Because this is getting 20 added to it, the x-coordinates will lose 20. And here's an example with cosine. So here, the cosine graph would normally hit the x-axis at 270. It's hitting at 290. So the graph's moved 20 degrees to the right. So this 90 has moved 20 degrees to the right. This is 110. This 180 has moved 20 degrees to the right. That's 200. The 0 degrees has moved 20 to the right. So everything's moved 20 to the right. That means you had to make the x-coordinates 20 degrees higher, which means in the brackets it must have said x minus 20. The peak is normally at 0. It's now 20 degrees more. It's at 20 degrees 4. And the minimum is normally at 180 degrees. It's 20 to the right. It's at 200 degrees negative 4. So that's the maximum amount of turning points. 20 degrees 4, 200 degrees negative 4. The graph has had A being 4 because it's been stretched 4. It normally oscillates around the x-axis. And it's 1 unit high. Well, it's now 4 units high, so that the y-coordinates been multiplied by 4. There's a 20 degree shift, and because it's 20 degrees to the right, the coordinates have gone up 20 degrees, so the brackets must have said minus 20 in it. So there it is there. So there'll be a worksheet where you have to figure out what A and B were and give them maximum minimum turning point. The exercise here can be downloaded using the link in the description. In this, at question 25, on to the end, 36, so there's 12 questions. From 25 to 36, that's this transformation, just like the examples there, and they will have answers with them. There's also a booklet you can download, this one, and when you go to question 19, there's questions of that form through to 24. So just from 19 to 24, there's answers at the back. And there's a set of notes that covers all the videos on trig graphs with some examples. So we've had 4 transformations in these videos. The next video will be about maximum and minimum values. I hope this video has been useful.